All right, click and closed, and let's have a look up here. I want to go through a couple things, a couple examples, and then I do want to leave you some time to work too, though. So I don't want to make this too long, but I think this is much needed. Because what our goal today is, what we talked about day before yesterday was we talked about introducing A, which is the vertical dilation factor. But let's remind ourselves what that does, right? The vertical dilation factor, that's telling us what we're multiplying all of the y coordinates by to either stretch a function vertically or squeeze it or compress it vertically, right? So there are a couple questions at the beginning of the last assignment like this. Okay, and you might, if you got this one wrong, so we're trying to vertically stretch this thing. Let me open up a new one here. Okay, so this time we're trying to vertically compress it. So if I put in a value like, let's say I put in 3, that's wrong. Okay, but you might be expecting it to give you back the correct answer. And it does this, it just says test. And you're wondering, what the heck, is this broken question? No, it's not. The reason it does that is because there are an infinite number of correct answers, and it tested your answer and it was wrong. Okay, that one didn't work. Let's find one that does work. Now, A is the number that's being multiplied outside the function. That's the number that's determining how much it's stretched or compressed. Well, the y values that we're calculating in our parent graph, we calculate from taking x to the 9th power, right? When we multiply A by x to the 9th, we're taking those original y coordinates of our parent graph, and we're going to either make them bigger or smaller. Do I want to make the y coordinates bigger or smaller if I want to stretch the graph out vertically? Do I want to make the y coordinates bigger or smaller? You know, comparing it to the parent graph. Start with the y coordinates of every point on the parent graph. If I want those points to be stretched up vertically, to the y coordinate, yeah, the x coordinates stay the same, but the y coordinates need to be bigger, right? What would I multiply something by is an example. There's an infinite number of answers. What's one number I can multiply something by to make it bigger? 2 would work. What's another one? 5. What's another one? 6. Yeah,
Any
billion.
number.
Well, not any positive number. Any number greater than 1, right? Any number greater than 1. So we could pick it. Now that's if I want to stretch it. This one's asking me to compress it, though. Okay. So if I want to compress it, what's a positive number that I could multiply something by to make it smaller? I heard a bunch of things. 0.1, 0.5, 0.9, 1/2 is a fraction, 1/3 is a fraction, 2/3 is a fraction. Any number that is less than 1, greater than 0 and less than 1, right? So what could work here? Wow, let's pick an easy one. Let's just pick like 0.1. And I really should put a 0 at the start. That's a good habit to get in. Okay, yeah. Does that make sense? Okay. All right, so moving on. Let's look at some other examples. So our goal now is we want to be able to do all 3 of these things at the same time. So this is what we need a little practice on. The dilating and, the dilating you get some practice on for sure, right? Stretching and compressing vertically. But remember, all you're doing with that, and we'll get some more practice today, all you're doing with that is you're multiplying y values, okay? So if I start off with some parent graph that's f of x, and I do these 3 things to it, I'm going to multiply outside by a, I'm going to subtract h from x inside the function, and I'm going to add k outside. That allows me to do lots of things to that function, to make it look a lot of different ways, because I'm going to be vertically dilating, stretching or compressing. I'm going to take the whole thing after I dilate, and I'm going to slide it to the left or the right based on the value of h, and I'm going to slide it up or down based on the value of k. All right? So let's try one of these. How about something like this? Okay, we've got this function 3 times the quantity x plus 7 squared plus 2. So first of all, what are the values of a, h, and k? What is a? A is 3. Good. Okay, here's A equals 3. What's H? No. -7. There you go. So based on, there's my +7. So H is the number being subtracted from X. So it's always going to be the opposite of whatever that operation is, right? So H is -7. And what's K? Okay, so what are the steps I would have to go through then to do those things to it? Well, the first thing I have to do is I always have to dilate first. Okay, technically, I have to dilate first. So let's do that. I'm going to take this function. Now, if I were to ignore all of the A's and H's and K's, what's left behind? What's my parent function going to be that I start with? X squared. Everybody agree? So my parent graph, call it P of X. How about P for parent? My parent graph, it'll be red, how about it? So P of X is just X squared, so let's start with that one. Well, that's an easy one to graph, right? I could just make like a t-table here. I'm inputting X values and I'm outputting Y values. So let's pick a couple points. So if I plug in 0 for X, what's Y? 0. 0. 0 squared is 0. So there's 1 point on the graph. 0, 0, right? What if I pick another convenient point? What if X is 1? What's Y? 1. Yeah, because 1 squared is 1. So I go over 1 and up 1. What if I pick X equals 2? 4. Okay, and that's probably enough for now, right? Go over 2 and up 4. Okay, and I can connect those smoothly, and I end up getting, let's see how my artistic skills are here. Not very good, but there's my parabola, right? Okay? So I need to dilate that first of all, though. So I got to multiply all of the Y values by A. What's A? 3. Okay, so I'm going to multiply to get the blue graph, which is going to be my stretched graph. I'm going to multiply all of the Y values. The X values stay the same. So what should my new Y value be? 0, because 3 times 0 is 0. So that one just stays put, right? How about this one right here? 3 times 1 equals 3. So I'm going to have a point that's over 1 and up 3. Right? And how about this one? 3, which is A, times 4 equals 12. So I'm over 2 and I'm up 12. So there's 4, 8, 12. Right? Let's try my hand at my artistic skills again here. See if I can do a little better this time. It's kind of a harder one to graph. Oh, that's terrible. That's pretty bad graph. You get the idea. I'm not an artist. Who's the math teacher? Okay, so we stretched it up vertically, right? Now the rest of it's pretty simple, right? If I'm going to translate this thing 7 to the left, because H is -7 and K is 2, well then I just end up with what are the coordinates of the special point, the vertex, going to end up being? -7, +2, right? Okay, and we get that from, these guys right here. If I just take these two into account, H is -7 and K is 2, and we just think of those as an ordered pair, and that's my vertex, isn't it? The vertex is at HK, and so that's going to be -7, +2. So we're going to take this point right here, and we're just going to translate it over 7 and up 2, and then we're just going to take that whole blue stretched graph and slide it to that place, right? So now it's here. So it's still tall and skinny, just like we made it, but it starts there instead of at the origin, right? Get the idea? Okay, now in practice, so you're going to have to, when you're making a graph of this, you can do it that way. You can do it in 2 steps on graph paper, and that's fine. That's fine to do. It's a little bit of extra work, though, to graph the thing, to dilate it first and then translate it. Could we come up with maybe a kind of a shortcut on this instead? Okay, I'd say we can. Okay, so let's take same problem, I'll show you my little trick here. You're going to like this. You got to watch this very closely, but it really pays off. Same problem exactly, right? We know that technically we have to stretch it first and then translate it. But why not cheat a little bit? Why not realize that, okay, we've already told me that the values of A, H, and K are 3, -7, and 2. You can already see by inspecting the equation that the vertex, HK, is at -7, +2. So let's go there. Let's just go to -7, +2. Right? And let's pretend that that's the origin. So now we're just going to kind of stretch it in place, but make the assumption that really technically we're supposed to stretch it first. So just pretend that that's the origin when we stretch it, but we've already slid it. Does that make sense? Okay. So I'm even going to draw in really lightly on here. I'm going to draw in an x-axis and a y-axis just to remind me. Okay. Now we got to do the dilation, right? So the dilation, we know that A equals 3, right? So we'll take our, I guess I've got the colors kind of backwards here. We're starting with the blue one. So our normal parent graph looks like this, right? We go over 1 and up 1. We go over 2 and up 4, right? And we've got to multiply those vertical shifts by 3 this time, don't we? Right? So from our new vertex, when we go over 1, how much do we have to go up? Yeah, 3 times 1, right? See what I'm saying? So this distance, this vertical distance, is going to go all the way up to there. So that's where that first point ends up. And then the second one's going to go over 2 and up 12. So it's way the heck up there somewhere, right? I don't know what I just did. And then we're back, right? So this one's going to be way up there somewhere. Now we get, and we only need one though, don't we? Right? There's the one that we need right there. And I can reflect it over this fold in the page. It's got that symmetry, right? The line symmetry. So I can just reflect that one over to there and get a freebie on that side. And so here's my graph. Right? You get it? Now in Moodle, what are you going to be doing? I'm going to give you like 10 choices or something. You just got to pick the right one. So all you really got to do is you got to know where's the vertex. Well, we found that pretty easily. And then from the vertex, what's it mean for the vertical dilation factor to be 3? From the vertex, we just go over 1 and up 3. Right? You get the idea? Yeah. Let's try one of those together, like in Moodle. Okay, so something like this. How about? So where should the vertex be? What are the coordinates of H and K? Okay, so let's summarize all that. We'll put everything over here. So H, K is, you told me, right? 4 to the right, so 4, 3, right? So we know the vertex is going to be over 4 and up 3, so the vertex is going to be right there. Agreed? Now what about the dilation factor? A is equal to what? Okay, so instead of going over 1 and up 1, how far should we go? Over 1 and up 6. Okay, so over 1 and up 1, 2, 3, 4, 5, 6. And I get another point over there, don't I? If I flip it over that line. And so I should get something like that. Well, let's just find the one that works. Is that the right spot? It's supposed to be wasn't supposed to be a 4, 4, 3, so, oh, that's it, isn't it? Boom. You got it. Okay. Gee, it's rapid. Okay. All right, last one. What about that? The 2/5 is kind of a doozy. Multiplying by 2/5. Okay, that's a weird one. It's not very convenient, is it? No. Right? So let's just think about, first of all, let's not even worry for a second about the translation part. Let's just worry about the 2/5 part. A is 2/5. So here's XY plane. Here's our parent graph, right? Our parent graph just does that. Now this is not drawn to scale, but let's just draw the convenient points on this graph. So we've got 1, you told me I go over 1 and up 1. I go over 2 and up 4. I go over 3 and up how much? 9. 3 squared. On an x squared graph, that's all this is just p of x equals x squared. I go over 4 and up how far? 16. And then finally up here I go over 5 and up 25, and I can keep going, right? Well, if I'm going to be multiplying y values times 2/5, which one of those is the easiest one to multiply? Which y value is the easiest to multiply by 2/5? Yeah, 25, isn't it, right? That's the y value that's going to work, because 25 is evenly divisible by 5, by the denominator. You see that? All these other ones, like let's just pick one at random. If I pick this one right here, I'm going to get 2/5, which is my value of A, times 9 equals 18/5. Yikes, that's a decimal or a fraction, right? That's hard to graph. So that one's not very good, but this one works great, right? If I do 2/5 times 25, I end up getting, I get 50 over 5, and I could just reduce that, couldn't I? 5 over 1. Either way, I end up getting 10, right? So this point right here should actually, it's going to get squeezed down to where it's at the point, let's put it right there, or how about right there? I'm going to put it at the point over 5 and up 10 instead of over 5 and up 25. And so the result is it's going to get compressed, right? So if we wanted to graph this one then, all we got to do is we just have to remember that the 2/5, that's going to squeeze this thing, so it's going to change the shape of the parabola. So instead of going over 5 and up 25, a convenient point is over 5 and up 10, right? Okay, so all we'd have to do is go to our vertex, which is where? Good. So over 4 and up -1, which is down 1, okay? And then we're going to go over 5, so 1, 2, 3, 4, 5. And up how far? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there's going to be the other point, right? And so the shape of this thing just looks like, so that's, what would those coordinates be? I've got 4, -1. So what's my new x coordinate going to be if I started at 4 and I went over 5? 9. And then I started at y equals -1 and I added 10 to that, so I get 9, 9. There you go. So I just get the parabola that has a vertex at that point and goes through that point. Does that make sense? Okay? Does that help? I could do more, but I want to let you work with that. Why don't you work and get questions answered? Sorry, did that help with the question you had?
Oh, mine's totally, absolutely valuable.
Okay, only difference is, it makes it easier actually, the only difference is your parent graph. So Connor, he had a question for me, and it was a similar question, but it was an absolute value equation instead. All we gotta do is we just have to remember what's the difference in the shapes of the parent graphs. If we have the absolute value of x, that's an easier one to do. I've got the vertex at the origin. I go over 1 and up 1. I go over 2 and up 2, right? So I just get that straight line instead of a curve. On the left side, I go back 1 and up 1, back 2 and up 2. See what I'm saying? So if I had an absolute value graph, let's say that's my parent graph, right? That's f of x equals absolute value of x. Well, what if I graphed this one instead? What's that one? That's g of x. What did I multiply f of x? What did I multiply by outside? This y-coordinate right here was 1. This one is 2, right? Everybody look at, pause what you're doing for just one, give me like literally like 30 seconds or less, because this will help. If we're trying to figure out what graph is this blue one, if we're comparing it to just an absolute value graph, well look, we know that, we don't know what A is, but that's what we're trying to find, right? I know that if I multiply A times my original parent y-coordinate, that's got to equal the dilated y-coordinate, doesn't it? So what's A? What times 1 equals 2? 2, right? Didn't I just double the y value? So we end up getting A equals 2, and so g of x is just 2 times my original function, right? Okay, go.